Welcome, everyone. I'm Dr. Jeremy Porter. I'm the head of climate implications here at First Street. And today we're talking with Dr. Jeremy Hoffman, someone who we've actually worked with in the past. We have, not a super long history, but again, First Street's not a terribly old organization either. But Jeremy's worked with us in a couple different capacities. One as a data user of our initial products. He's also a co-author on our extreme heat model and has just put out some really cool research around the connections between historic redlining and climate risk, which really can be extended and translated into other discussions around climate and environmental justice and other discussion points. But I'll start off by just asking Jeremy, maybe you want to introduce yourself and just give kind of a high level overview of the project.
Yeah, thank you, Jeremy. Hello, I am Jeremy Hoffman. I'm the Director of Climate Justice and Impact at Groundworks USA, an affiliated network of 21 place-based environmental justice organizations around the country. And I also enjoy appointments at the University of Richmond, as well as Virginia Commonwealth University. And so real quickly, this work focuses on a really important question: the long-lasting environmental implications of a practice widely known as redlining. And so basically a historical practice of denying access to financial investment tools and wealth building tools to particular neighborhoods based on their race and class. And that the long-term implications of what that meant almost 100 years ago in the present day, where we have a rapidly shifting climate that is exacerbating things like extreme heat and extreme rainfall that then relates to flooding. So I worked with a really amazing team, Ariana Salazar Miranda, who is joining Yale, a student, Claire Konzelman, who is at the Federal Reserve Bank of Richmond, as well as my colleague Tuan Phan, who's also at the Federal Reserve Bank of Richmond and one of the co-authors on the Fifth National Climate Assessment's economics chapter. So we had a really unique team that came together, to really dig into establishing a highly robust estimation of how significant these environmental risk differences are across these redlining grades.
Great, yeah, and I'm super interested in both the methodology that you dug into, the data that you ended up using on the analysis, also the implications. I think the take-home implications are really powerful from this project. But maybe just to start off, tell us a little bit about what motivated you to explore the relationship between historic redlining and climate risk.
Yeah, so the story kind of begins several years ago, even to a paper we published in 2020, but work that we started doing as early as 2017. My colleague Vivek Shandas and I had started doing these high-resolution studies of air temperature and how that varies across different urban contexts around the country. And we started recognizing that the same sorts of patterns of heat disparity along race, especially race and economic and income levels, were basically being recreated over and over again in the cities that we were working. So that kind of consistency has to kind of beg the hypothesis that there's some sort of unifying system at work, some sort of thing that exists in American cities that would lead to this disparity being so consistent along these socioeconomic kinds of dividing lines. And so it turns out that, around that same time, the University of Richmond had digitized the Homeowners Loan Corporation's redlining maps, which are now kind of, ubiquitous. I think a lot of people understand and know what those refer to. But basically, in a nutshell, these redlining maps are the physical manifestation of what was a very common, pre-held, dominant form of real estate and social, the way that the real estate and urban planning world worked at that time was that neighborhoods of color and poorer neighborhoods and immigrant neighborhoods were just automatically worth less investment. They were riskier for investment. They held this innate, risk in them. So redlining came out of some, Chicago-based activism in the 1960s and 70s, where basically it's defining that you are, kind of drawing a red line around a neighborhood and saying, stop any sort of investment in this place. Now that, while it's kind of a practice, this is the actual physical representation of that in a map. Like you can look at these maps and see where these people from the Homeowners Loan Corporation physically drew the lines around these neighborhoods in different colors, corresponding to their grades. And much like your grades in school, it goes from A, the best, to D, the worst. And those D areas were outlined in red. And so the motivation here was very much around, like, if we can start to see the disparity in heat exposure across cities unified through this lens of decisions that were made in the early 20th century, that's a pretty compelling case for understanding why and where to go to act first to keep people safe in the changing extremes of the present and into the future. So like it was really, really unique that I think in 2020 we first published this paper just looking at surface temperatures. Some other people had started to look at urban flooding disparities using First Street Foundation data. And really the interest here too comes from the need to, motivate really dramatic climate adaptation investments, and not understanding how that kind of investment should be, driven by communities that are frontline exposed, as well as, serving as a way of like economically boosting these neighborhoods at the same time. It's really one of those things that unless we look at how history informs the present, we might inadvertently, do the same kinds of negative things, make these decisions in an uninformed way that might further exacerbate these inequalities. So there's both kind of the interest in understanding why heat disparity exists and what are the drivers of heat disparity, not only in the physical sense, but the historical sense. And then how does that history then inform our decision-making for investments in climate adaptation and resilience into the future?
Yeah, no, and just the work that we did together, even a few years back when we were building the heat model, we know that land use and land cover is one of the most significant predictors of risk in terms of relative risk across urban areas. So if you start thinking about that and putting the pieces together with your points that you're making, the historical linkage to investment in parks and investment in green space and other types of protective measures really starts to play out in your models, which is really, really cool. Maybe we could step into the methods just for a minute. I'm a quantitative modeler. I really kind of geek out over the models and the methods a little bit. Talk a little bit about the methodology that you used on the model, and really thinking about how you integrated First Street data into the model. But beyond that, the sort of clever approach that I found in the paper was starting to look at some of these comparisons across folks that were in these red line districts versus folks that weren't in the red line districts, and some of the approaches you used to make those comparisons. Maybe you can tell us just a little bit about that.
Yeah, so I mean, I have to credit the first author of this paper, Ariana Salazar and Claire Konzelman, who really dug into the kind of theory behind these boundary design methods. And so this is a really elegant application of this approach. And so it was originally, used to help detect kind of changes across an explicit boundary where you might not otherwise expect there to be a change in something. And so basically that's like you're trying to detect a change over a physical kind of boundary. And it's been used across economic and environmental literature. But basically what we've done is to construct along these kind of polygons where they drew on the map. You can see here, this is a map of Baltimore, is basically to identify properties that were either on the lower graded side or the higher graded side of these Hulk polygons. So again, they have grades from A to D. And so by looking at the properties on either side of this boundary, which is, presumably if they're like across the street from one another, there shouldn't be really that many things that are that different about the immediate geography. It's like one of the, best and most important things in geography is that close things are more alike than things that are very far apart. So it's this is kind of frames what this methodology really tries to do. And that's basically to really narrow our focus to this subset of houses and properties that should otherwise be very comparable. They have the same kinds of, land use around them, same elevation, slope. They're close, within a few hundred feet. We have a buffer of about 100 meters where we're looking at this. But really the only thing that differs is this grade determined by the HOLC. And so by isolating as many of these different like fundamental environmental factors, and it turns out we also worked on a bunch of socioeconomic and census data to isolate as many of those factors as possible. And the only remaining thing, or at least the best of our ability, the only remaining thing to be different about these properties to be the redlining grade, we're then isolating what that treatment must have been to the outcome, which is flood risk and heat risk from the First Street Foundation's data sets. And so sorry, go ahead.
No, go ahead. I cut you off, but I was gonna say that's really interesting. Maybe as you're going to continue to answer this question, one of the things that I really find, is a really important tool in building out these kind of models is the ability to control for all these other factors that people, generally attribute to it. They'll say, well, maybe it's the socioeconomic indicators, maybe it's the demographic indicators, but what you're finding is that holding all of that constant, it is the actual spatial location within the HOLC boundaries.
Right. And I mean, talk about such a unique improvement from like, our original paper just looked at the entirety of that geography and considered that all to be, homogeneous. And what's really great about this method is that, yeah, you were trying to hold as many things constant and in a sense, like correct for whatever sorts of differences might be there because of that thing. And by isolating and removing that, we're only left what's explained by the outside factor, which is the HOLC grade. And so by doing that, this really kind of sophisticated, boundary design, we find that for all of those things being the same, the heat risk and the flood risk both increase basically monotonically as you go down in HOLC grade. So the worse the HOLC grade, the higher the accompanying risk in flood and heat from the First Street Foundation data, which is just like, I mean, it builds and it confirms largely what we have found in the past, but with this much more robust approach to estimating what that effect is. So it's a really, really, I think, and the fact that we use the individual property level data that's in the First Street data, I mean, that's really what I think one of the primary contributions of this analysis is that we've used this kind of boundary design, which helped to detect economic differences across these boundaries, but applied it now to these environmental and climate risk data, which I think is really what the big advancement of our contribution here is.
Yeah, no, that's great. And I was gonna, just kind of tease the data a little bit as you were talking through that. The contribution, I think, of having the property level high resolution data, in our estimation at least, in the development of these hazard models, gives you the ability to uncover findings that maybe could be hidden if you had lower resolution data. Of course, you want to make sure that the data is appropriately created. It's been vetted, it's been peer reviewed, all the things that we generally do in the development of these models. But maybe you could just say a word or two about the importance of having the high resolution data as an input into the model.
Well, that and enabled us to really explore like more about the having that parcel level identification then not only gave us the flood and the heat risk at a very high resolution, but it also allowed us to then look at other data sets that we have and select just for that place. So it really is about hyper localizing what we're talking about, and not allowing just like a bunch of parking lots and things like that to be part of the analysis. Like we want to look at where people are, where the properties are, um, what are the characteristics of those properties. And so by incorporating this very hyper local high resolution data, we then are able to have a much more nuanced and representative and robust effect. And then we can explore more about that effect. And
Yeah.
furthermore, then further, when we get back to the implications of this is you can start to then look at where are those properties that have the highest risk of them all, and then you start to prioritize your action based on that information. So it really does just build on top of each other, both like the robustness of the data and then the implications for that socially and economically are huge.
And that just kind of hit home with me. I mean, when you're building these high resolution models at the property level, it helps to inform where you're allocating resources and how to efficiently and effectively do that to help the people most in need of sort of those adaptation features. But if we just shift gears a little bit, and maybe not too much, but conceptually, you introduced a topic and a concept of environmental capital. And so as you're thinking through environmental capital, and that environmental capital could be at city level, it could be a zip code level, it could be at the property level, it could be at the neighborhood level. But maybe you just talk a little bit about the impact of on environmental capital that the redlining that you found within these different redlining areas.
So part of the issue with previous work has been we've been struggling to establish like what's the mechanism that leads us from the 1920s and 1930s and 1940s.
Yeah,
leads us to the present in huge disparities in flood and heat risk. Like what's the thing that gets us there? Well, working in climate related issues in urban areas, we all know that there are a lot of different things that provide climate risk mitigating advantages in urban areas. Things like trees, green spaces, pervious land covers that can allow for, water to percolate through them, trees shading, lowering the temperatures, and as a proxy for like the ability to stay out of a flood zone, like the height of your foundation, for example. So it was really a really clever idea from Ariana and our author team was to approach this idea of proxies for what is environmental capital, like the ability for your neighborhood to absorb those climate risks naturally through like green infrastructure or otherwise. And so what's really fascinating about that part of the analysis is that and how does this tie back to like the redlining determination? Is like if your neighborhood was given this really poor grade, then your property values, we already know in the present day, like lower credit scores, lower property values, lower home ownership, and so on. All of these things then relate to generational lack of resources, both private and public, to then have those climate mitigating advantages in your neighborhood, like parks or healthy tree canopy campaigns, or having the ability politically to engage in the process. If you were locked out of it because of redlining, then your neighborhood was then also potentially bulldozed for the interstate system and your neighbors were displaced. And so there's all of these different ways that this system of early 20th century urban planning would have then led to a legacy of disinvestment in these particular places. So we create these proxies for this capital, this environmental capital, and perhaps unsurprisingly, mirroring our results from the increasing climate risk by grade, we also see a diminishing environmental capital. And so by incorporating that at that property level, we're able to do the same kind of analysis, just looking at these indicators of environmental capital. And so I think what's important about this is that this is yet another important contribution, as we're putting this out there as something that we can probably look at, follow the money, and you could establish whether this is true across the board or not. But even with what is definitely a highly local process of budget determinations and things like that, there's still this large scale general pattern of the echo of redlining on these particular climate mitigating features of our neighborhoods, which is really incredible to have observed.
Yeah, and to quantify that and to be able to link it back statistically, especially that negative relationship that you pointed out, is fascinating to me. I wonder, you talked a little bit about this, but maybe you could just talk a little bit about how the research builds on past research. I know you've done some work in the area. Your work is an extension of past work that you've done, but there's also other literature in the space. Maybe you can just kind of situate what you found relative to that.
I think this is we're entering, the last, since 2020, when our paper certainly wasn't the first one to look at, redlining in a particular place, nor was it the last. There's been such this bloom of research, both economic, and I think that this really reinforces the findings from those studies. This kind of this translation between the economic outcomes to then having a lasting, indelible mark on these neighborhoods through environmental capital, I think is really interesting. But also the public health side of things needs to be talked about in this space as well. Is like there is so much public health research showing how disproportionately poor health outcomes are by these same health grades. So you have, higher incidence of asthma, you have higher, maternal mortality during childbirth, you have, a variety of other sorts of, chronic illness types of things that are linked to this redlining. So what I think to me is that I think our contribution here, the economic contribution, and then this kind of health outcome, that makes the social determinants of health. Like one of these really important frameworks for understanding why do some neighborhoods have such lower life expectancies. It's because of these echoes of these policies from 100 years ago, echoing through our economic, social, and environmental, context. And so I think it's an incredible transdisciplinary look at how climate risk is superimposed onto and by these other influences that I think is what I hope comes through as people read our paper and see some of the references that we have. I think it truly is this physical addition to the economic and health portions of the literature that just start to really show just how important decision making is, and how a decision that's made by a few people that then has an effect on many, it better be, focused on equitable outcomes for all, because this is one of those, it's just so hard not to see it once you've seen all of the evidence together like that.
Yeah, I think and as a as a social scientist, I generally would say, the processes and concepts that we study, they happen in specific places based on context, and they happen in specific locations because of either temporal moments or because of historical vestiges of what we've seen in the past. So being able to tie all of that information together and to be able to then link it causally back to redlining and a sort of an observable trend of increasing exposure to extreme heat, of increasing exposure to flood risk, I think really does nail down the patterns. For me, as I read the paper, those are kind of the main takeaways that I saw. Maybe as we kind of close out our discussion today, maybe you could just highlight some of the unique contributions, the places where you think that the paper really does push us forward in terms of our understanding of some of these relationships that you've seen up to this point, and kind of where do you go from here? What are you thinking about next in terms of your own research?
Yeah, so I guess first and foremost, the headline statement is we find a persistent and causal relationship between redlining in the sense of the HOLC redlining maps and these present day climate risks. And so while redlining itself is again, it was like a practice, it was a thing that there's a lot of evidence for it, but HOLC is by far the most compelling and direct evidence that we have of its being put into reality and put on paper. So I think key thing is that I think we've established now a very consistent, robust, significant estimation of and using this very high resolution data, we have a very good and numerical estimation of by just how much formerly redlined neighborhoods experience climate risks like extreme heat and flood risk than their non-redlined counterparts. I think that's by far the most important take-home point. But I think there are also two other really important contributions. One, the use of this parcel by parcel level data from First Street Foundation is, I think, also a really unique way to start looking at these like kind of historical perspectives on climate risk. So I think that that's one really interesting additional contribution. And I think also this unique and novel use of this boundary design to detect historical implications on present day, and then even future climate risk, I think is really a unique, a really cool contribution to the field. As far as like what comes next, at Groundwork USA, like I said, we're an affiliated network of these environmental justice nonprofits in 21 cities, many of which were redlined. And so our work is using, funneling these information to the communities that are experiencing these disproportionate risks, working with them to advocate and, first of all, develop a vision and a voice for what they want in the form of climate adaptation projects, and then actually going out and advocating for it and attracting investment from private as well as public money. We're at the precipice of this. Well, we're in the middle of it too, the early part of this historic investment into climate resilience and climate adaptation projects. And so if the communities that have been left behind by these processes that we identify in this paper are not included or not prioritized in this historic investment, we might inadvertently reinforce and exacerbate and recreate redlining in a different way by not using this information as like the North Star for what we're doing. So what's next for me and for this work is really to put this to practice and apply this work to community engaged, trying to do shovel-ready projects in these places to cool them down and make them easier or alleviate their flood risk. At the same time, I think there's also something to be said about including, not only including the members of these communities and these neighborhoods in developing and co-producing these ideas for what they want to see done in their neighborhoods, but also in getting them interested in monitoring the outcomes. So can we track, can we find the impact of these investments by training individuals, empowering individuals from these neighborhoods to actually pick up the tools of science and go out and measure the impact of these things so that we know that what we said we were going to do is happening. So I think it's like kind of like twofold. It's like, I hope it continues to inspire additional research in this way and an application of our method to other questions. But I also think taking this information and putting it into the hands of those that need it the most to advocate for changes in their neighborhoods that need to happen first is like quintessentially what I think my mission, and I know the mission of Groundwork USA is very similar. So that's what's coming next.
And it begs the question on follow-up, what are some of the solutions that could be implemented in some of these places, especially when we're talking about flood risk and heat risk to one hyper local, the other one feels a little bit more disparate and harder to adapt to. Maybe you just talk a little bit about those solutions. Yeah.
Oh, so there are so many dramatic examples from the Groundwork Network. I have the pleasure of working with over a dozen of these projects that are happening right now. So for example, in Cincinnati, Ohio, in the Lower Price Hill neighborhood in Cincinnati, the Groundwork ORV has recently installed a green roof on a school that is part of a entire resilience corridor that they are working with the residents to actually implement. It includes tree planting. It includes air quality monitoring and mitigating sources of air pollution at the same time. So that's really exciting, inviting nature back into our cities and areas with very low environmental capital. We want to invite nature back into those places. Reclaiming land in New Orleans. Groundwork New Orleans is currently totally reshaping land that is underneath the highway overpass that was constructed and bisected the historically Black neighborhood there in New Orleans to make way for the interstate highway system. So what they've been doing is creating a very large stormwater park. And just a couple of weeks ago, it endured almost 8 inches of rain, falling in a matter of hours. So you can't think of and what's really great about that project is it employs members of the community that are, from the community, and learn how to build these things and maintain them and create an economy around green infrastructure that mitigates flood risk along that corridor. And then I'll say one last really cool one, but I could talk for days about all the cool work in our network. But Groundwork Elizabeth, New Jersey, has been planting microforests, and microforests are a very dense planting of trees in a small area, and the competition really seems to spur very successful, durable, kind of resilient ecosystems. But not only that, they're natural air conditioners, but they also absorb a ton of stormwater. And kind of the story is that next door to one of these microforests, a person that used to experience a bunch of flooding in their basement no longer does, because they have this, microforest next door. But that's the kind of work that now we're doing, is we're establishing how do we measure the implications of these, 1% solutions that we're putting everywhere that will eventually add up to 100%. But how do you assess that 1% by 1% in different places? It's a really exciting time.
Well, it's fascinating. I think the work that you're doing at Groundwork USA, I think the research that you've done with your co-authors in terms of connecting this in a structured, systematic, highly rigorous way in the research paper that you published has really been interesting to me, to be able to see the connection in the scientific research. But it's just been fascinating and really interesting to talk. I appreciate you coming on, talking to us about the research paper. Dr. Jeremy Hoffman, Groundwork USA, thanks so much for being on today and talking about the research. And I hope we get to do this again soon.
I hope so too, Jeremy. Thank you so much for the invitation. And I'll look forward to more collaborations in the future.
Great. Thanks, everybody.